Good afternoon. I'm back here at Embedded World 2024, and I'm pleased again to be joined by Jason Kridner, who is the co-founder and president of the board at BeagleBoard.org Foundation, and Robert Nelson, applications engineer at DigiKey. So again, thank you very much for joining me. It's a pleasure. This time we're going to chat about Risc-V, if that's okay.
Oh, that's great. That'll be awesome.
So can you give us a bit of an overview of Risc-V and its significance in the current technology landscape?
So Risc-V is a new instruction set architecture, but it's an open source instruction set architecture. That doesn't mean the CPUs themselves, the designs are open source. Some of them are, a lot of them are, but it means that the specification for the binary code that those processors run is open source, so that anybody can create code and anybody can create a processor that runs those instructions.
Yep.
So that means there's a lot of different CPU vendors creating CPUs that will run the same software, right? And they can have very, very differentiated hardware, right? It still runs the same software so that you can have common binaries across the world.
Yep. And you get to a situation where you don't have one vendor controlling the ISA. It's community developed, community learned, and yeah.
So how has the adoption of Risc-V grown over the last couple of years? Because it's quite a big buzzword at the show this year.
It's been astronomical for sure. I think interest is amazing, but the number of people that are popping up developing CPUs is it's staggering.
And you'd be surprised nowadays to find out that so many devices we have today, actually, a lot of them have Risc-Vs.
They have Risc-Vs, right? And they're already shipping.
Yeah.
All over the place. You don't see and hear about it as much, right? Because it's not so much on like the phones and the laptops and the servers yet.
Yeah, okay.
Right.
What are some of the challenges we're facing with Risc-V at the minute then?
Starting from scratch is the big one.
Yeah.
When you're starting with a new ISA, there's things that, like in the other worlds, like security bits, security functions, they don't really exist right away. So the first couple of generations of Risc-V, there's some things missing in the API.
Yeah.
Which, for example, one of the boards we did,
But the vector instructions?
like the vector instructions.
Yeah. So, because things are so early, our highest performance Risc-V board is the BeagleBoard Ahead.
Okay.
And it leverages an Alibaba TH1520. And when they implemented the C910 CPU core that's inside of that, they implemented it with the 0.71 specification of the vector instructions. But we were really happy with working with the Risc-V community because they've now worked this to get support into GCC for those pre-ratified instructions, right? Using the XTHV extension to the compiler. So now people can use GCC 14 and get the full performance out of that C910 processor, right? So it is a very collaborative community, but we see times where people move at different paces and generating these different CPU cores, but they still find a way to make it all work.
Yeah. And can you tell us a bit more about the security features, around Risc-V and how they compare to other architectures?
I'd say the big thing about that is just that there are security instructions on it.
That's good.
And then brand parts.
Yeah, I mean, I don't know too much about the security features of Risc-V myself.
So no, this is one of the reasons why some vendors haven't switched to Risc-V yet. Is a lot of the security things aren't quite in place yet.
Right. Okay.
Like
Makes sense.
the big one is ARM Trust Zone.
Yeah.
But they do have hypervisor capabilities, right? And we are shipping boards with processors that have hypervisor capabilities in Risc-V, along with secure coprocessors, right? So there's a C906 in the TH1520 that can provide some security functions. I wouldn't be able to dive into any of the details of that, though.
Or maybe you have a security processor you want to design.
So let's sort of...
Yeah, this is a different board. This is the BeagleBoard Fire. And what's special about this was it includes FPGA fabric inside of it.
Fantastic.
So it also has a quad-core Risc-V And this one has a lot of high-speed I/O in it, along with the programmable FPGA fabric. It's certainly possible to work with the microchip tools to secure this system. I wouldn't be able to go into the details of that either. But if this is a great way to prototype new ideas and get really ultra low latency control systems done.
Yeah. And when was this one released? Was that last year, wasn't it?
Last November, I think.
Last November.
Yeah, late November. And when we were talking about Open Beagle earlier, we have CIs running with Libero already on this.
Yeah.
So you don't have to install Microchip's tools. You can just clone a repo and you can build your own gateway firmware on these devices.
Yeah.
Without...
Sorry. What would you say differentiates your implementation of Risc-V from other Risc-V platforms available on the market?
I think BeagleBoard has a real commitment to longevity and support that maybe a lot of other kind of pop-up Risc-V board vendors might not have, at least not have established yet at this point, right? We've been around, that we're going to be around, and that you're going to be able to get support for these Risc-V platforms and get them for a long time. The BeagleBoard form factor provides a whole lot of I/O, and we're going to work on making the developers' experience something that an average Linux user can do, because that's kind of what we are. And
so that's kind of the challenge with an FPGA design. We're Linux developers. We're not FPGA. We're not VHDL Verilog. Thank you, Cyril.
Cyril works at Microchip and has been providing us with a lot of help on the gateway.
Without his help, this would still been a couple more years.
Yeah.
But he's enabled us to go and create new gateware spins, right? Yeah. Because we can start with his repository on OpenBeagle and fork it and pull from Verilog examples. I've done blinky LEDs and Cylons, and because we've got LEDs directly tied up to the FPGA fabric for just kind of doing some playing around. We're working on instantiating our own CPU cores in here, but it's also real easy to go and do different things that we've done with Cape headers before, like I2C and I2S and UARTs. You can just write the tickle script. I want these on these different pins, and you save it into the OpenBeagle. The CI infrastructure that Robert's helped set up will run the Libero tool and generate a bit stream and a device tree overlay. You copy that onto the board and you run a script on the board. It reprograms it on the board. So I'm not getting out JTAG tools or all the other stuff that FPGA developers would do, but Linux developers, we don't like to do that stuff.
Yeah.
And the other cool thing of the CI that we've done pretty recently is now when it builds it, you also get a Debian package. And so you can actually have a fleet of these in your own area and have your own fork of gateware and push updates to your apps. And just through Libero.
Package feeds and auto updates and then get your gateware updates.
So the sheer package to download is just basically the apt-get upgrade.
Who is your sort of key target audience for this? Are we talking makers,
education, advanced professionals? Pretty much everyone that's interested in FPGA.
Everyone that's interested in FPGA, absolutely. I think automation. It's if you need, where do you use FPGAs, right? And a lot of times it's when you need some low latency controls, right? Which is a lot of Beagle users have done a lot of. So there's a lot of interest in the Beagle community for this board.
Yeah.
Because they can do really ultra low latency controls. We also have a lot of I/O bandwidth on here. We've got the syzygy connector that's hidden in the back here, but they've got the 12.7 gigabit per second SerDes transceivers on there, and so you can get a lot of I/O, high throughput and low latency, right? So people dealing with a lot of data that they need processed in real time.
A couple things we thought about internally was CI developments. Well, you want to test all your I2C sensors, SPICE sensors. How many micro headers can we make on this?
Yeah.
And then other people have asked us, although this is the 025 chip, what about ratification changes? What if we want to test Risc-V changes on other cores?
So maybe we need more FPGA gates so they can load larger cores into the FPGA fabric. So that's been a very often requested thing from the community is a higher end version of this board, and so that's something that we're considering and taking feedback from the community on now.
Yep.
So Keyford comments coming on the forum on that.
Excellent. So, I mean, following on from that then, what development tools and programming languages are recommended for use with this? And are there any new tools introduced alongside this product?
It's safe for us as far as BeagleBoard is the whole Libero stack for a microchip. That's something we've never had to deal with because we've always done Linux, GCC.
Yeah.
And so we're not Verilog guys. So it's a whole big stack for us.
Yeah.
Yeah, so the Verilog and VHDL are kind of the easy ones to kind of plug into the example framework that we've got right now. Although you kind of to instantiate some of the existing IPs over the M2, the syzygy, or the Cape headers kind of rather easily. But I'm expecting to see more integration with open source tooling, things like FuseSock and other tools to be able to pull from other IP libraries more quick and easy. So I think that's one of the first places we'll see is be able to pull in from more open source IP libraries. But eventually we would like to see more of the tool chain being replaced from proprietary tools to more open source tools.
And what's the feedback from the community been like since the launch?
Really good.
Yeah. The community really loves this board.
Yeah.
They've given a lot. And it's like the biggest complaint was use a bigger one, but
yeah, they just want more of it.
Well, speaking of that then, what is the future roadmap for you when it comes to Risc-V?
That's the most obvious thing is maybe more FPGA fabric. I think looking at maybe the future families that might provide higher performance native Risc-V cores. With the TH1520, I think it's just getting more of that software infrastructure out there, improve the state of software for Risc-V in general. It's a really great build platform. It's not like what you maybe traditionally think of as a build platform, but it's actually a really, really great build computer because it is a very high performance Risc-V, and it's readily available, and you can throw lots and lots of them in the lab and make some pretty nice big Risc-V build farms with it.
Excellent. Watch this space then.
Exactly. Stay tuned to the forums.
Exactly. Well, thank you very much for bringing it along for us and for introducing us to it. So thank you very much.
Thank you.
Thanks.